We're going to talk about trigonometric ratios today. First, you need to know how to label a triangle, and this is most specifically a right triangle. So triangle ABC, the angles are capital letters. The side across from the right angle is always the hypotenuse, always. And then the straight sides, the other two sides are called legs. They are the side opposite to angle B. You'll notice that side is opposite to angle B, but it is adjacent to angle A. And then this side is opposite angle A, but adjacent to angle B. So now we need to find the trigonometric ratios for angle A. So first we have sine of A. Sine is equal to the opposite side of A divided by the hypotenuse. Cosine of A is the side that is adjacent to A divided by the hypotenuse. And tangent A is the opposite side from angle A divided by the adjacent side of angle A. Very similar for angle B. Sine of B is the side opposite to B divided by the hypotenuse. Cosine is the side adjacent divided by the hypotenuse. And tangent is the side opposite to B divided by the side adjacent to B. So let's try one. We have this right triangle. The sides measure 3, 4, and 5. And we have this angle theta right here. So first we can go ahead and label this. Opposite of theta is 4. Adjacent to theta is 3. And the hypotenuse, again, is always across from the 90-degree angle. It's 5. So let's find the trigonometric ratios for theta. Sine theta is equal to the opposite divided by the hypotenuse. So the opposite divided by the hypotenuse, which is 4 divided by 5. Cosine of theta is equal to the adjacent side divided by the hypotenuse, which is 3 divided by 5. And then tangent theta is equal to the opposite divided by the adjacent, which is 4 divided by 3. And that's as easy, as simple as trigonometric ratios gets. However, we can also use these trigonometric ratios to calculate the angle that we don't know. So again, we've labeled this triangle. And so angle A, this angle right here, is equal to the inverse. This here is inverse sine. So the inverse sine of its ratio, the opposite side to A divided by the hypotenuse. In order to use this on your calculator, you must first do second and then sine. And then type in your ratio. Or you can find angle A by doing inverse cosine of the side adjacent to A divided by the hypotenuse. Again, use the same ratio for cosine. Or you can find A by using tangent inverse. Opposite side to A divided by the adjacent side of A. Same thing for angle B. Inverse sine of the side opposite to B divided by the hypotenuse. Or inverse cosine of the side adjacent to B divided by the hypotenuse. Or inverse tangent of the side opposite to B divided by the side adjacent to B. So, in this little disclaimer here, we want to make sure that we have our calculator in degree mode. So, let's find the measure of angle theta. First thing is very important, you label your triangle. So this is the opposite, this is the adjacent, and this is the hypotenuse. Again, opposite, adjacent, and hypotenuse are labeled. So in order to find theta, theta is equal to inverse sine of the opposite divided by the hypotenuse, so 8 over 17. You could also find theta by doing inverse cosine, which is 15 over 17. You could also find theta by using inverse tangent, which is 8 over 15. Now, any one of these will work. You do not have to use all three. If you have all three sides, then you can pick whichever one you're most comfortable with. I'm most comfortable with the sine function. So, inverse sine of 8 divided by 17 is 28.1 degrees. All right, ladies and gentlemen, that's trigonometric ratios.